Look up. What do you see? During the day, you see a brilliant star, our sun. It hangs in the sky, a giant ball of fire. It feels so far away, yet it is closer than any other star. It warms our faces. It lights up our world. Everything we have ever known, every person who has ever lived, did so under the light of this one star. It is the engine of our planet. Imagine waking up one morning and the sun is gone. Not just hidden behind clouds, but completely absent from the sky. A deep, unnatural twilight falls over the world. The familiar warmth on your skin vanishes, replaced by a sudden biting chill. Panic would spread faster than the darkness. The world's scientists would race for answers, but the immediate effects would be undeniable. Without the sun's light and heat, our planet would begin to freeze. This is the first, most brutal consequence of losing our star. One of the most famous examples is the year without a summer in 1816. In 1815, a mountain named Tambora, in what is now Indonesia, erupted with incredible force. It was the largest volcanic eruption in recorded human history, a blast so powerful it was heard thousands of kilometers away. The Tambora eruption threw a colossal plume of ash, dust, and sulfur dioxide high into the stratosphere. This fine veil of particles spread around the globe, acting like a dirty mirror. It reflected sunlight back into space before it could reach the ground and warm the Earth. Global temperatures dropped by as much as 3 degrees Celsius. In Europe and North America, the summer of 1816 never truly arrived. We need to go back 66 million years, to the end of the Cretaceous period. This was a world teeming with life. The dinosaurs had ruled the Earth for over 150 million years. They were the undisputed masters of the planet. A giant asteroid, estimated to be about 10 kilometers wide, slammed into the planet. The impact itself was cataclysmic, unleashing more energy than billions of atomic bombs. The asteroid's impact vaporized rock and sent a tremendous cloud of pulverized dust into the upper atmosphere. This immense cloud spread rapidly, wrapping the entire planet in a thick, impenetrable shroud. For months, or possibly even years, very little sunlight could pierce the gloom. Without sunlight, photosynthesis stopped. Plants on land and plankton in the sea died off en masse. An attacking civilization could achieve this by redirecting a large asteroid, or a volley of smaller ones, to collide with the planet. It's basically a cosmic game of billiards with devastating consequences. A massive impact would vaporize rock and soil, throwing trillions of tons of fine particles high into the stratosphere. Once there, these particles would be carried by high-altitude winds, spreading out to form a global shroud. A barrage of powerful nuclear weapons, detonated at strategic points across the planet's surface, could also work. Multiple airbursts would ignite massive firestorms, sending vast quantities of smoke and soot into the upper atmosphere. This black soot is incredibly effective at absorbing sunlight, leading to a rapid and severe drop in global temperatures. A nuclear winter would be more than sufficient to collapse agriculture and plunge a civilization into a dark age. Instead of fouling the planet's own atmosphere, an attacker could create an artificial ring of dust in orbit around the target world. The idea is to build a structure composed of trillions of tiny independent objects. Together, their collective effect would be to create a permanent diffuse shade, dimming the sunlight that reaches the surface below. An advanced civilization could use automated mining drones and mass drivers to grind celestial bodies down and fling the resulting dust into precise orbit. The density of the dust ring could be adjusted to control the exact amount of sunlight being blocked. The attacker could choose to merely dim the sun, triggering an ice age and agricultural collapse. If the attackers wished to later use the planet, they could deploy fleets of robotic cleaners to gradually remove the dust from orbit. It wouldn't arrive with a bang, but with a slow, inexorable dimming of the sky, a creeping twilight heralding a long, cold night. For a truly advanced civilization, they could opt for building a giant solid structure in space to block the sun. It would be a colossal artifact, an umbrella of unimaginable scale. The ideal location would be at the L1 point, which lies directly between the planet and star. The construction would be a monumental undertaking, requiring the complete disassembly of moons or asteroids to provide raw materials. The final structure could be tens of thousands of kilometers in diameter, a fragile-looking but incredibly strong sheet blocking the life-giving light. Once in place, it could be controlled with exquisite precision. The shield could be tilted to adjust the size of the shadow. The attacker could use the shadow as a threat, a bargaining chip in a planetary hostage situation. The sunshade is more than just a weapon, it is an instrument of absolute power. The civilization living in its shadow would be constantly reminded of their helplessness, living at the mercy of the beings who stole their sun. When we consider a truly ancient and powerful civilization, their methods might not involve crude matter like dust or giant physical shields. A civilization that has mastered gravity could potentially create a localized gravitational lens, placed precisely to bend the light from the star away from the target planet. Perhaps such a civilization could create a miniature, stable black hole and place it in the L1 Lagrange point. A microscopic black hole would be more than sufficient to act as a perfect, immovable sunshade, casting a shadow of absolute darkness. An alien intelligence might work with dimensions. It might be possible to rotate the planet slightly into other dimensions. From our three-dimensional perspective, the planet would simply seem to grow dim or even disappear from view. This is a truly alien form of attack, one that would be utterly incomprehensible to a civilization like ours. There would be no visible weapon, no dust, no shield, just a slow, inexplicable fading of reality itself. When the sun begins to fade, the first casualty is not life, but hope. Imagine the world's reaction as the sky slowly, unnervously darkens day by day. Scientists would confirm the terrifying truth. The dimming is artificial, an act of aggression from an unknown power. The psychological impact would be immediate and devastating. To have that stolen would shatter our sense of place in the universe. The most immediate crisis would be the collapse of the global food supply. All surface crops would wither and die within weeks. Supermarket shelves would empty. Governments would fall as they fail to feed their populations. As the cold intensifies, the next system to fail would be the power grid. Our energy infrastructure is not designed for an Arctic deep freeze. The final stage would be the breakdown of social order itself. Communities would turn on each other, fighting over the last scraps of resources. Even in the face of total collapse, humanity's story would not necessarily end. We are a species defined by our adaptability. This would drive a great migration, a desperate search for sanctuary. They would seek out regions with intense geothermal activity. Vast underground cities could be carved out, powered by geothermal vents. These deep shelters would become the last bastions of civilization. In these underground cities, vast hydroponic farms would be built, illuminated by high-intensity LED lights. Society would be highly structured and communal, with every individual's role focused on the collective survival of the Ark City. Generations would be born who have never seen the sun or an open sky. Their legends would speak of a surface world and a great light that was stolen. It would be an engineered existence, a life lived entirely within artificial confines. This is the great adaptation. Humanity would endure, not on the sunlit plains, but in the deep, warm darkness below. While many would focus on mere survival, others would refuse to accept their fate. In the deep cities, the brightest remaining minds would gather. They would not be content to simply live in the shadow of their enemy. Their goal would be singular and audacious, to fight back. Their first priority would be to understand the enemy. Who are they? Where did they come from? What technology did they use? They would turn every remaining radio telescope towards the sky, searching for any sign of the attacker. They would analyze the nature of the shadow itself. Is it a dust cloud? A giant physical shield? Understanding the weapon is the first step toward defeating it. Once the nature of the weapon was understood, the resistance would begin to devise countermeasures. They would have to build and launch missiles or high-energy laser systems from their subterranean bases, aiming at a target over 1 million kilometers away. The resistance would work to preserve the dream of a sunlit world. They would become the keepers of the flame, ensuring that knowledge of the past was not forgotten. Let us imagine they discover it is a colossal, solid sunshade, parked in the stable L1 Lagrange point 1 million miles away. With the target identified, the next monumental task is to figure out how to destroy or disable it. They would have to repurpose their deepest geothermal vents into colossal launch silos, a desperate plan to strike back at an unseen enemy. The weapon of choice would likely be nuclear-tipped missiles. These would be relics of warfare, now repurposed for planetary liberation. Each missile would be a desperate prayer, launched from the depths of the Earth on a one-way journey into the void. The missiles must survive the launch, navigate the hostile environment of space, and strike a distant moving target. It would be a battle of machines, a silent, deadly ballet fought in the vacuum between worlds, with the fate of a civilization hanging in the balance. Imagine the moment of victory. A missile finds its mark. The distant sunshade shatters into a million glittering pieces. But the darkness remains. The fragments now form a dense cloud of debris, an unpredictable shroud that continues to block the sun. The survivors would need to embark on the largest civil engineering project in their history, Project Daybreak. Its mission would be to actively clear the skies. The first phase would involve building a fleet of robotic sweepers. These would be specialized spacecraft launched from the underground cities. Using nets, lasers, or electrostatic charges, these drones would begin the painstaking process of collecting the fragments. Larger pieces might be pushed into new orbits, sending them crashing into the sun or flung out of the system entirely. If the attack had used atmospheric dust, scientists might propose seeding the stratosphere with materials to make particles fall as dark snow. It would be a slow process of healing, watching the sky gradually shift from oppressive black to murky twilight, and finally back to brilliant blue. The day the first unfiltered ray of sunlight touches the frozen surface would be a moment of incredible significance, celebrated as the true end of their long night. But this moment of triumph is also the beginning of a new challenge, the long thaw. The world has been an ice ball for generations. Now, with the sun's warmth returning, the planet will begin to wake up in a violent and unpredictable way. It will be a period of immense geological upheaval. The oceans, once covered in a thick crust, will begin to stir. The sudden influx of fresh water could disrupt ocean currents for millennia. The atmosphere will thicken as frozen gases evaporate, leading to chaotic superstorm weather patterns unlike anything in recorded history. The survivors would have to remain in their deep shelters, waiting out the planet's violent rebirth. When the climate finally stabilizes, the survivors can begin the great return to the surface. Generations who have only known underground cities will emerge into a world both familiar and alien. The sky is blue, the sun is warm, but the landscape is a barren wasteland of rock and mud, scoured clean by ice and flood. They would need to bring life back to this sterile world. Teams of biologists would lead the effort, reintroducing genetically engineered microbes and grasses to create new soils. They would establish the first surface settlements, powered by the sun they fought so hard to reclaim. They would plant the first forests and reintroduce the first animals from cryogenically preserved embryos. It would be a slow, careful process of nursing a dead world back to health. Rebuilding a global civilization would be the work of centuries. The people of this new dawn would carry the lessons of the darkness with them, a profound understanding of their dependence on their star, and a deep-seated caution about the silent, watching universe. We have journeyed through a thought experiment of cosmic proportions. We have explored the chilling possibility of stealing a star's light. From the brute force of asteroid impacts to the elegant precision of a giant sunshade, the methods are varied. They range from the barely conceivable to the truly godlike. Blocking a planet's sunlight is perhaps the ultimate weapon. It is not an attack on an army, a city, or even a nation. It is an attack on the biosphere itself. A civilization capable of such an act would have immense power. They would be true masters of their cosmic neighborhood, able to move asteroids and build structures on an astronomical scale. It is the ultimate expression of power asymmetry, a demonstration of technological superiority so absolute that it renders the victim helpless. As our own civilization grows and reaches for the stars, we too will develop greater technological power. We are already learning to deflect asteroids and harness solar energy. The very technologies we might develop to protect ourselves from natural disasters could, in theory, be turned into weapons of unimaginable destruction. The story of weaponized darkness is therefore a cautionary tale. It is a reminder that with great power comes great responsibility, and that the path to becoming a truly advanced civilization is fraught with profound dangers. Beyond the science and strategy lies a deeper, more troubling question. What kind of civilization would ever choose to use such a weapon? To deliberately extinguish the light of another world is an act of profound moral significance. It is a decision to commit deicide, to kill the god of a planet's biology. It implies a moral calculus that is utterly alien to us, a way of thinking that sees the annihilation of an entire biosphere as a justifiable means to an end. This question forces us to look in the mirror. It compels us to think about our own ethical development as a species. Contemplating such an act also reveals the incredible preciousness of our own world. We exist in a delicate, life-sustaining balance with our star. Every ray of sunlight that warms the ground, every plant that reaches for the sky, is part of a miracle that has unfolded over billions of years. Ultimately, the act of blocking a sun is an act of supreme arrogance. It assumes the right to pass judgment on an entire world, to decide that its inhabitants and ecosystems are worthless. The mark of a truly advanced civilization might not be the power to extinguish a star's light, but the wisdom and empathy to never, ever use it. Why do we tell ourselves these stories? Why do we ask these grand, unsettling questions about blocking suns and destroying worlds? The value of this thought experiment is not in its literal prediction, but in the perspective it gives us. Thinking about how a civilization could be destroyed forces us to think about what a civilization is. By imagining the loss of sunlight, we are forced to appreciate, perhaps for the first time, its central importance to everything we are and everything we do. These cosmic-scale questions stretch our imagination. They push us beyond everyday concerns and connect us to the vast, awe-inspiring stage of the universe. They are an exercise in humility. They remind us that our world is a small, fragile island in an immense cosmic ocean. The challenges we face as a civilization, climate change, resource scarcity, existential risks, require us to think on a planetary scale. The fictional scenarios of survival and global cooperation force us to think about how we might solve our own collective challenges. They are test beds for the kind of long-term, species-level thinking we will need to survive and thrive in the centuries to come. So we must continue to wonder. We must ask the big questions, even the scary ones. What is out there? What is possible? What does it mean to be a civilization? By looking up at our sun and imagining what it would be like to lose it, we learn more about ourselves. We see our dependencies, our vulnerabilities, and our incredible resilience. We are reminded that our future is not guaranteed. It is something we must build and protect together. The single constant star in our sky is a daily reminder of this truth. It is the source of our life, the engine of our world, and a beacon of hope, as long as we have the wisdom to cherish its light.